Okay, so here we have the device running at 0 hertz. It's not moving at all. And then we'll start to take up the motor hertz a little bit at a time. The pan won't start to register vibrations from the accelerometer until around like 7 or 8 hertz. So anything below that. Alright, so here we go, the motor's going. Okay, so the equipment will start running at around 11 hertz. So right now at 10 hertz, you can see nothing's really, the motor's spinning, but it's not really getting any natural frequencies out of this just yet. If I go a little lower, you can see there's a natural frequency there, but it's not the one that we're aiming for. And so now let's see, that's 7 hertz. So if we go up to, let's get into that 11 hertz range. We're going to start going through some vibrations. All right, now you can hear things are starting to respond a little more as we're hitting that 11 hertz. And now you can see the motor's at 11 hertz and the pan is really responding. So at this point, this is where the engine, where the system wants to operate, is at this 11 hertz range. And you can see now the pan's frequency, which is being calculated from that accelerometer. The pan's frequency matches up almost perfectly with that of the motor. Alright, so anyways, at this point, this is pretty much the speed, we eased into this real slowly, so this is pretty much the speed the motor wants to run at. So I can put my hand on this system, I can put my hand right on the center. I can stop it or with as much weight as I can put on there, I can stop this system, and it still continues. And that's just because the motor doesn't want to leave where it's operating right now. So now, in order to get some more amplitude out of this, let's start adding more power to this. And you can see that as I've added more power, rather than the motor going faster, it's kind of stuck at this 11 hertz. So as the motor's rotating, I add more power to it, rather than spinning faster, it's caught up in this kind of like vibrational well, this sort of frequency, or the natural frequency of the system is keeping the motor from spinning faster, because as the weight's getting thrown around, it's actually just throwing more and more energy into it, and rather than speeding up the frequency of the motor, it's actually just getting more amplitude out of this system. So let's see, I'll back it back down. We're still at that 11 hertz range on the motor, but we got much less frequency. So now I'll add some more energy to it. We'll stay around 11 hertz. It doesn't really speed it up much at all, and you can see I get much more. So let's see how far I can push it. So you can see now I've got almost an inch, depending on where you measure it, and almost an inch of displacement. And so the thing is, if I give the motor enough power, eventually it can break out of that kind of natural frequency well that it's in. It'll have enough power to break out of that, and then the frequency is going to speed up a lot. So let's see what happens. I'm going to add a little more power, and now you can see the system has stopped moving, and it sounds like there's not any energy in it, but if you look at the frequency here, the motor is actually spinning very fast, and even the pan's vibrating at that speed. So the accelerometer, even with this little amount of vibration, you can barely see it. The accelerometer is able to pick that up. So at this point, we're not going to hit any more natural frequencies of the system. We're just going to have some weird things. Here's another natural frequency happening. This one's interesting because it's very close to the frequency that the video is captured at. Alright, and this is about as fast as the motor can go, so let's back it back down. So anyways, there's lots of little natural frequencies there. At one point the table started moving when it hit the right natural frequency, but the one that we care about is isolated, and that is right at this 11 hertz. So here we go again, and everything oscillating as expected, and I can even add some more power to it and still keep it at that 11 hertz range.